Bunch of the stuff we're doing today with this multiplying by a monomial, we're going to be using the product rule. So just keep in mind something like 3x cubed times x squared, right? We did this in our Unit 9 exponents unit. The product rule has us adding those exponents, right? Because I have all those factors of x. So just keep that in mind. That's not new, right? That's from Unit 9. So, but that's going to be popping up a bunch today. So as you see in example 1, we have a linear monomial times a linear binomial, right? And I can do the distributive property here. What's x times x?
X to the second.
Yeah, x squared. And then x times 4?
4.
It's 4x. All right? So, again, no new skills here, actually. We're just putting together skills that we haven't put together before. We've multiplied things and added exponents. We've done distribution, right? We've written in standard form, right? So the result of this, it's kind of cool. We have a quadratic binomial. So our resulting polynomial is a different polynomial, right? By classification. Let's check out example 2. I'm going to distribute my 5m cubed to everything. So like when I just multiply like that, like 5m cubed times 3m squared, that's like a question from Unit 9, right? You guys seeing that? That's like kind of not a new thing. I would not write it out like that every time I'm just showing you. So what I'm going to do is distribute everything. So 5m cubed times 3m squared. I'm going to multiply the coefficients together because I can. 5 times 3 is 15. Then I've got an m cubed times m squared for a total of m to the 5th, right? So that's just that first term, my monomial times my first term. My monomial times my second term, I'm going to get minus 5m to the 4th. And times my third term is minus 35m cubed. Now, can I combine these terms?
No.
No. So I had someone earlier today say, like, well, Mr. Mack, you always say nothing's magically connected. Well, that's true. I do always say that. But when we were working on all those simplifying expressions with exponents, the only operation happening was multiplication. And if it's all multiplication, order doesn't matter, right? So you can mix it all up and do whatever you want. Here, we have subtraction, multiplication. We got to mix, right? So the order of operations would not allow us to do anything with these unless they're like terms. Are you seeing the difference? Before it was all multiplication. Do what you want. Mix it all up. This, you could mix it all up within a term if there was something to do. But since we're separated by these subtraction symbols, you can't mess with anything else because you can't just go in any order you want. Because there's the order of operations. Okay, it's different. All right, so I want you to try out on your own right now numbers 1 through 4. Let's check out 1 through 4. K times k, k squared. K times negative 9, minus 9k. We good? All right. Number 2, I got 9a squared plus 9a. Looking around, looks like we're all good. All right. Number 3, negative 6p to the 5th plus 48p. Looking around. Remember, p is a p to the first power, right? Number 4, negative 6c to the 6th minus 15c to the 5th. Looking around. Cool. So I want to look at number 9 with you. Looks different, right? There's like more letters. No new concept here. When I multiply, right, I can multiply this to this any order I want. So I'm going to multiply the p's by the p's. Well, p times p times p times p times p times p times p is p to the 7th. And q times q times q times q times q is q to the 5th. You see what I'm saying there? Like, it looks crazy because there's a bunch of letters, but nothing too crazy. I'm going to distribute to that second term minus p to the 3rd, q to the 4th. And then I'm just going to make sure this is standard form. So I got 12th degree and 7th degree. Perfect. 12th and then 7th. That's standard form. We're good. All right. Why didn't I need any coefficients? Why didn't I need to multiply any coefficients?
Because there aren't any.
They're all 1. What's 1 times 1? 1. Simple. All right, so let's check out 10 together. So 10, I got a 3x cubed y for my monomial times my first term in that trinomial. We'll multiply by my second term in the trinomial. I'm going to get plus 3x squared y squared. I'm going to multiply by the third term in that trinomial, and I get 3xy cubed.
Mr. Mac, why is the lesson called? Oh, okay. Oh, you get the first one and divide.
We keep distributing a monomial, yeah. All right, I'd like you to try 11 through 14. I get they're a little tougher than some of the previous ones. Make those good mistakes and we'll tighten it up, okay? I changed my mind a little bit. I want you to do 11 and 13. Let's save a little time. I think we're going to be good if we just get 11 and 13 done. All right, let's look at number 11 together. I'm going to distribute that monomial, 5r squared s squared, to all three of these terms. Boom, boom, boom. Okay? I'm going to get a negative 10r to the fourth s squared. I'm getting a 15r cubed s cubed. And I'm getting a negative 20r squared s to the fourth. Everything's to the 6th degree, so I don't need to redo anything. Cool? Bueno. Let's look at number 13. Ooh, I got this monomial times this binomial. No more trinomial right up in here. All right, let's do it. Negative 63, c to the 5th, d to the 4th, plus 28, c to the 4th, d to the 7th. If this is your answer, minus 1/2. Here's why. It has to be written like this. Who can tell me why? Oliver? Standard form, highest degree term has to come first. If you made that mistake, good mistake. I was tempted to make that mistake, and then I counted. 7 plus 4, 5 plus 4. I can see how it would be a pretty easy mistake to make. Okay, so you might look at 23 and be like, dang, that's a lot of numbers, bro. And I'd say, why do you talk to your grandma like that? But no new concepts here. As I'm looking at this, I know I'm going to distribute a couple times. And then what am I going to look to do? Combine like terms and put it in standard form. No new skills. But we got to be organized. Write slower, write neater, and don't sass your mama. Okay, so let's distribute this monomial negative 2r. We get negative 2r to the 4th. I'm going to distribute to that second term, plus 12r cubed. Distribute to the third term, minus 12r. Okay, this plus 4r cubed just chilling. Okay, sorry, bro, you got to stay by yourself. Then I'm going to distribute that negative. Minus 5r to the 4th, minus 10r. Whew! 1, 2, 3, 4, 5, 6 terms right now. But good news is, remember that zombie problem from the beginning of the year?
No blankets.
No blankets. We're going to put our spoons with our spoons and our blankets with our blankets. So, check this out. You guys see these r to the 4ths? I got negative 7 of those r to the 4ths. Now, this is just organizational, but I like to do this. Whoa. Cross them out, baby. I used them. They're gone. Then, oh, I did something on here. Okay. Then, see these r cubes? Boom. Put them together, man. We got that many r cubes. We got 16 of those. We used all the r cubes up. And I like to slash out, because like, let's say there was another r cubed and I missed it. If I didn't slash it out, then I kind of know I didn't use it, right? Then, I got these straight up r's. A negative 12 and negative 10 for negative 22 of those r's. There it is. Negative 7r to the 4th plus 16r cubed minus 22r. I've got myself a quartic trinomial. Okay, what looks different about number 24? Brackets, which are just parentheses that are kind of squared to show that you have kind of like parentheses inside of parentheses. So the first thing I'm going to do is I'm going to distribute that negative 5. You guys seeing that? Okay, so I rewrite everything. 4b. I got a 2a squared minus 15ab plus 10b squared plus 29ab squared. So I don't mess with brackets. I'll just double parentheses like a real rebel. Okay. So all I did so far is I distributed that negative 5, that monomial negative 5 to that binomial inside of the parentheses. Well, now, do you notice what's outside of the parentheses now? Got that 4b. That 4b now can get distributed to all three of those terms. And that gives me 8a squared b minus 60ab squared plus 40b cubed plus 29ab squared. Now what, though?
Simplify and like.
Yeah, simplify.
Simplify for each step.
Those two are the same thing. So a squared b minus 31ab squared plus 40b cubed. They're all third degree, so it kind of wouldn't matter order there, right? Well, it kind of does. B cubed has to come last because alphabetical, but there's no a there. So. But do you see how, like, if you look at it, it looks crazy? You break your big problem down to smaller problems, nothing's too crazy, right? There's more opportunities to make a little mistake because there's lots of things going on. But, you know, get organized. You notice how I like kind of underline things sometimes? It pulls my eyes to those things that I'm going to combine and stuff. Let's check out this trapezoid. Can anybody remember how I remember the area of a trapezoid equation?
No. You flip it over.
Remember, I can like make the short side.
You just take it off.
You can make the short side a little longer and the long side a little shorter. Make yourself a parallelogram by finding the average of your bases. So I'm starting here. That is area of a trapezoid equation. The average of my bases times my height. Remember, it works because it makes those bases into a parallelogram. Do you guys remember that at all? I hope. Okay. So now I'm starting here. I know my bases, I know my height, so I'm going to substitute it into my equation. So 1/2 times. I got a base of 8x squared plus 3x. And I've got a base of 2x cubed minus x. Times the height of 4x squared. So all I did was I put in my bases and put in my height. I haven't done anything computationally yet. I just substituted it.
How do you find the average thing again?
1/2. You add two things together, divide by 2.
Oh.
So that's, I haven't actually done it yet, right? It's just in my equation. That's how I memorize my equation. Okay. Then there's a couple options of what to do next. Here's what I'm going to choose to do next. I'm going to multiply. See how there's like 3 things to multiply? This, and this? You guys seeing that? I'm going to multiply my 1/2 times 4x squared first. You know why? Because that's 2x squared. So I multiplied my 1/2 times my 4x squared to get my 2x squared. All right?
Is the 4x squared outside the parentheses?
It is, but it's like 3 things are being multiplied. I can multiply those 3 things in any order I want, right? The things 1/2 times this times this. Okay, next thing I'm going to do is I'm going to tighten up inside my parentheses. I've got 2x cubed plus 8x squared plus 2x. So all I did was I combined my x terms from in my parentheses. Right? In my parentheses, I had 3x minus x. That's where that 2x came from. Do you see how I'm kind of just chipping away, making my big problem smaller problems? Okay? Now, I have a monomial times a trinomial. I'm going to distribute that. Get 4x to the 5th plus 16x to the 4th plus 4x cubed. And that is, well, I did 2 times 2 is 4, 2 plus 3 is 5, 2 times 8 is 16, 2 plus 2 is 4, 2 times 2 is 4, 2 plus 1 is 3. Yeah. So again, this is one again that's going to be tough. Like if you're like, okay, when I see a trapezoid, I do this. That's brutal. I broke it down into small problems. Like, oh, area of the trapezoid is this. Here's what I know. Let's chip away to simplify, right? It's no like, do this when I see this, okay? It's not going to work well. So who can explain to me how I'm going to find the area of the shaded part below? Oliver, what do you think?
6x times 8x minus 1 minus 2x times 5x plus 3.
Yeah, so you're going to need it to look like this. Do you see that you're going to need those parentheses in the parentheses, kind of?
Yeah.
Because you need to take away that whole unshaded region. Okay? So it's not a negative 2x. Your 2x needs to be a 2x for the whole area we're going to take away. So we're going to distribute here to start and distribute here to start. I've got 48x squared minus 6x minus 10x squared plus 6x. So again, I'm just chipping away. All I did was distribute my 2x to my 5x plus 3, and I distribute my 6x to my 8x minus 1. You guys see I got to distribute again, though?
The negative.
I got to distribute that negative. So I'm at 48x squared minus 6x minus 10x squared minus 6x. So I got some x squares I can combine right here for 38x squared. And I got a negative 6x and a negative 6x for a negative 12x. Way simpler looking, right? So the total area of the shaded region's 38x squared minus 12x. And you might be like, what does that mean? Well, that's all this is in like ratios to each other, right? This is 2 times an amount. This is 3 more than 5 times an amount. And this is 1 less than 8 times an amount. It may be one way this could maybe be like a thing, for example, is like, let's say you're a person who designs parks. And this is a basketball court, and this is grass. And you have like scale models, and like you design, depending on your area, you want your ratio of courts to grass to be the same, your ratio, right? Well, guess what? If you get an x that changes, this value right here, that'll work for any of those parks you design. Small, medium, large, doesn't matter. Because that area is going to change in ratio because it's all based in relationship to x. So that's like one way something like this could be used. Every time this guy builds a park or this woman builds a park, they just need to change their x value, and their ratios will stay exactly the same. Because once you substitute in an x, you can get area. And where would you rather substitute an x in? Up here or down here? Oh, yeah. Way better. It's the same value, right? But that's where that comes from, working with ratios and geometry, okay? And you'll see some of that next year, hopefully, too, in geometry. All right, y'all. Your homework is the 3rd page, odds as well as number 20. Odds and number 20. Let's get after it.